Tree of maximum value is similar to tree of minimum value. You're just going to start with the arcs that have the highest weight and work your way down. The biggest weight I have is 11. I'm going to start with this 11. Can I add this 11 without making a circuit? Yes, I can. And after the 11, I don't have any 10s, but I have a pair of 9s. There's a 9 and there's a 9, and I can add them both without making circuits. Then I have a 7 is my next lowest, and I can add that without making a circuit. After the 7s, I have some 5s. This 5 I can't add. If I add this and then back to A, and there's your circuit. We can't do that. Put a little X on the A to F. This 5 is okay. I can select it. Then the only one left is this 2, but this 2 makes a circuit. E to F, down to B, over to A, and then back to E. That is a circuit. We can't have that. The 2 is out. You don't have to put these X's on the arcs you're not using. It's helpful if you have a lot of arcs. It helps reduce the confusion and clutter. This is the tree of maximum value. All right, let's try this one. We start with the arcs that have the highest weight. The highest number I have in here, it looks like 11. I'm going to start with this 11. You might get confused. Is the 11 with this line or that line? There's a little very faint line that goes perpendicular to the arc that it's attached to. If you're not sure, click on the arc and it'll light up the weight. We know it's this 11 is attached to E to H. This 11 is attached to F to G. Then I have no more 11s. I have a 10 that I can add without making a circuit. I have another 10 here that I can still add. It joins them all up. After the 10s, I don't have any 9s. I have an 8, but that makes a circuit. We would end up with a circuit that looks like G to H, to E, to D, to F, back to G. And we can't do that. This line is out. The next lowest is I have some 5s. I have a 5 here that I can use. It's not attached to anything, so it doesn't make a circuit. This 5 I can add as well. I have this 5, but it makes a circuit from H to D, back to E, back to H. There's our circuit. Can't have that. This 5 is out. After 5s, I don't have any 4s, but I have a 3. I can use this 3. Look at that. If I select this 3, I don't have any circuits because there's no way to get from F to C, and then you go down the branches, you're stuck at A. You can't get back. There's no other way back. Not a circuit. This 3 is okay. Then I have some 2s. I cannot add this 2. If I add it, I end up with a little triangular circuit that looks like A to B, to C, back to A, like that. This 2 is out. This 2 is out as well. We end up getting a very long circuit. If I went from A to D, up to F, and then down to C, and then back to A, there's my circuit. We can't have that. This 2 is out. This 2 is out as well. If we went from G to C, up to F, over to G, there's our circuit, and we can't have that. This 2 is out. The last one, we have A to E, to C, to F, down to D, and up to E. That doesn't work. The 1 is out. What we have is our tree of maximum value. All right, and that's how you do tree of maximum value. Have a good day.